Us into our next bit of coding, which is the data operations section, or the red section. Now that we can get a color sensor value from the color sensor, what do we want to do with it? We can do certain operations with a value or number type value. And that's what we'll be exploring in this data operations section. So let's move on to the first bit of information. Variables, the known unknown. So variables are an important piece of code. So think of variables like boxes. They contain a value until you want to take that value out and use it. So variables can also be used to clean up code and simplify the complexity. So let's suppose you wanted to have the same speed of let's suppose you want to have this your robot go on for like 3 rotations, then 4, then 3 rotations, then 3 rotations, then 3 rotations, but then all the speeds are different. You can have the variable dragged out to each specific location rather than using 3 rotations for each one. It just cleans up the code and it allows it to a source number, which is easier to track. Like I said, variables also allow the user to change a parameter in one spot rather than changing all the values, all the other values. And let's watch this video for a little more information about variables. Alright, so now let's talk about another coding feature, the variable. The variable can be found in the Data Operations Center or the red tab, and the variable is the first block to the left. So now what is a variable? A variable is a value assigned to a name. Let me elaborate on that. Here we can change or put in a variable name. So a variable has two parts to it, a write command and a read command. In here we can put a variable name or add or create many variables. You can have more than one variable, and variables can be used in different ways. So we have the write command and we have the read command. The write command tells the variable that it has a value of a certain number. So let's say we want to have a value of 30. Then what it'll do is the write command tells test2 equals to 30. So when we drag out the read command, it says, ooh, I remember from before, test2 equals 30. So this value will equal to 30. So that's basically how a variable will work. So now let's suppose we wanted to do this. Let's suppose we wanted to go on for 5 rotations. So this would make the robot go on for 5 rotations. But you may be asking, why do that when you can just manually input 5 rotations like this? There are a few circumstances where you may want to use a variable. So let's take a look at them. So let's suppose that you always want to be going on for 5 rotations. However, the speed is different, right? Suppose the first one speed's 40, then it goes up to 60, then it goes down to 10, alright? Suppose the speeds are different, but it's always going to be 5 rotations. Let me just reset these all to 1. So, let's suppose we want to do that. So, let's all set them to 5. Right. So now they're all set to 5, right? This way, what we just did is we manually inputted each value. We went in and inputted each value. However, we could also just drag out this data wire once and then input 5 from here. So that's one way, an application of using a variable. So now this is where variables are very prominent. What were to happen if you were to change all these values? What if you wanted to change all the values to, let's say it was too much. Let's say you want to go 4 rotations. You have to go and manually input 4, 4, 4, right? That takes a lot of time. So, let me just, so let's suppose you already had this done. You already have all these variables dragged out. And let's suppose that you wanted to do this to 4. Boom. That was much faster than inputting each specific value. And especially when your code gets very long and you have the same value a bunch of times, and that you want it to be the same value a bunch of times, variables are very useful in that situation. You can have more than one variables. You have the write command and the read command. And you have to use both variables inside a program. You can write the value, but you're not doing anything with the value if you're not reading the value or dragging it out. And you can't read the value if there really is no value that there is, if you haven't set the value or written the value. And those are some common problems with variables, and that's basically how to use variables. Variables are a small piece of code, but they make a big difference. Watching that video, you saw how we can use variables to clean up the complexity of the code. And that's pretty important because your code can get really messy sometimes, and having one specific location to change all of your code in saves time and just makes it neater and easier to understand. So now let's talk about math blocks. Math blocks are what they sound like. We can do math with certain numbers. So we can do math on up to 4 values using the advanced. But for simpler terms, we'll just be looking at the 4 most common forms or uses of the math block, which is add, subtract, divide, multiply. So the math block can be used to perform operations on values. We can do many different operations. There are just more than those basic 4 operations. And we can do this thing called scaling. And we can also use threshold values. But this video I'm about to show you will explain a whole lot more in detail about what I'm about to talk to you. We have the math block. The math block is a very useful block. We can use it to perform certain operations, like scaling and using a threshold value to get the distance off from a certain number. Let's talk first about scaling. Scaling, or multiplying by a proportion, is relatively simple. The math block can be found in the data operations center, and it is the fifth from the left. The math block has a bunch of different operations that you can perform, but the most useful ones are add, subtract, divide, and multiply. Let's talk about scaling now. Scaling is multiplying one number by a constant factor. Now, what do I mean by a factor? A factor is a constant number that no matter what other input number that you put in, whatever you're multiplying it by will not change. So what I can do is I can drag a variable out. Let's put in this as the input value. Let's put this as the input value. So remember our variables. We're gonna write a numeric value, and we're gonna read a numeric value, and we're gonna put that, if I can just drag that, into A. Then what we can just change it here. So let's just say the input factor is 50. So now let's say we want to scale something down by 50% or divide it by 2. What we can do is we can put 0.5 dividing it by 2, assuming b used to be equal to 1. And this will allow whatever this input value is to be multiplied by half or divided by 2, and that will produce an output value, which is this equal sign. So let's look at a real application. Suppose we wanted to, let's just suppose we wanted to go straight on. Let's go on for 5 seconds. Yeah, let's do 5 seconds. what'll happen here is if this is not there, what'll happen is on this motor, both motors will be on 50 power for about 5 seconds. However, if we were to do this, then what'll happen is that B motor will be at half power because we're multiplying it by 0.5 or dividing it by 2. So then it'll become 25 power, meaning that this robot should steer to a certain direction. Here I will now put the constant value of what this will do going in a straight line for 5 seconds. So let's watch these videos. Alright, after watching those videos, you saw how scaling the number down increases a turn. But what happens if we were to multiply it by a bigger proportion? Let's say 2. Now what will happen is that this number will be multiplied by 2, therefore increasing the value in operation. So now let's run this. I'll have this one on the left and this one on the right, like in the other video. Okay, now, after watching those two videos, you saw how it turned to the other direction this time. And that's all because of this proportional factor. This input and this output have one thing in common, that they have to do something with this B value. And that's because we're multiplying it. And that's basically the gist of scaling and using the proportion in EV3 Mindstorms. Now let me show you threshold values. Threshold values are very useful if you want to find the distance off from a number. Let's suppose that we want our robot to be close to a 50-degree gyro angle. Okay? It's running constantly at a 50-degree gyro angle, okay? What we want to do now is we want to set our target value to 50. So let me just drag out a few variables again. You know what, let's not do that. What we'll do is we have our target value of 50. Then what we want to do is we want our gyro angle to be in here. So what's going to happen is that if this gyro angle is equal to 50, then what'll happen is that this robot will go on at 0 steering. And if it's not at a gyro angle of 50, then what'll happen is it'll do some steering to get back on course, assuming we multiply it by a negative 1, because the gyro sensor needs to be inverted. Otherwise, it'll keep on turning in the direction that you have it coded in. Like if it's started at 20, then it'll keep on going to 50, 30, 500, on and on and on. So if we multiply it by this -1 and this equals into the steering, this will make the robot go on at a constant gyro angle of 50. And that's basically the gist of scaling, threshold values and all that kind of stuff, because this is the threshold value. It's taking the distance off 50. And threshold values are extremely useful in the way that in our proportional line following code, you will watch and see how useful they are. But that's a bit more advanced. So just, yeah, watch this video and try to understand it, because this plays a very important part, especially these two math blocks, because they practically control a lot of how our code operates and runs.